be doing FRQ from number 5 from 2010. This problem says the function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 equals 5. The graph of y equals g prime of x. The derivative of g consists of a semicircle and 3 line segments as shown in the figure above. So the first problem says to find g of 3 and g of -2. Since they already give us the initial condition that g of 0 equals 5, you're going to use the fundamental theorem of calc to find these two values. So starting with g of 3, you would do g of 0 plus the integral of 0 to 3 of g prime of x dx. And when you're finding the integral, you are basically finding the area under the curve. So you would look on this graph from 0 to 3, you're going to find the area of this section and this section. So they give you g of 0, which is 5, and then finding the area under this is pi r squared, which is the radius is 2, so 2 squared, and because it's a quarter circle, you would divide it by 4, plus the area of this triangle, which is 1/2 base, which is 1, times the height, 3. So what you end up getting, this would cancel out because that becomes 4. It would be 5 plus pi plus 3 over 2, which ultimately becomes 10 over 2 plus 3 over 2 plus pi equals 13 over 2 plus pi. For g of 2, a g of -2, you do the same thing. So you would do g of 0 plus the integral from 0 to -2 g prime of x dx. Because this is from 0 to -2, you would just flip it, so that becomes g of 0 minus -2 to 0 g prime of x dx. And then when you're finding that area, this area is basically the same as the one that we did in the first part of the problem. So it's 5 minus pi 2 squared over 4, which becomes 5 minus pi. So for part B of this question, it says find the x-coordinate of each point of inflection of the graph of y equals g of x on the interval -7 to 5. Explain your reasoning. So if you think about it, the point of inflection occurs where g double prime of x changes signs, which in this case is when the slopes change sign. So on this graph g prime, you can see that at this point right here, it kind of like levels out. So it goes from a positive slope to a negative slope. So that is where one point of inflection would be, which is x equals 0. And then another point of inflection is right here, x equals 2, because it goes from a negative slope to a positive slope. And then right here at x equals 3, it goes from a positive slope to a negative slope. So x equals 0, 2, and 3 are all points of inflection because this is where the slope changes signs. For part C of this question, it says the function h is defined by h of x equals g of x minus 1/2 x squared. Find the x-coordinate of each critical point of h where x is greater than 7, and less than 5. And classify each critical point as the location of a relative maximum, minimum, or neither. Explain your reasoning. So to find the critical point of a function, you actually have to find the derivative of that function first. Since they gave us h of x equals g of x minus 1/2 x squared, you have to find the derivative of that. So you get g prime of x equal, or minus x. And you would set that equal to 0, because that's what a critical point is where the x equals 0. And you would get g prime of x equals x, which is basically y equals x. So I'm going to draw the line y equals x on my graph. You can see where it crosses the points on g prime of x. So this is a rough sketch of what it would look like. And we need to find this intersection here. And since this line goes straight across this point, we know that one of the critical points is going to be x equals 3. But to find the other intersection, we actually have to find where the function equals 0. So by looking at this semicircle, we can find that the equation of g prime of x is x squared plus y squared equals 4. And we're going to solve for y. So y squared equals 4 minus x squared. And you square root both sides to get y. And then we're going to set square root of 4 minus x squared equal to x. And you square both sides, and you get 4 minus x squared equals x squared. So you get 2x squared equals 4, and x equals square root of 2. So this is another critical point. So to determine whether these critical points are relative maximums or minimums, we have to look back at this here and see how h prime of x is defined. So by looking here, we can say that h prime of x will be positive anytime g prime of x is greater than x. So we have to look on this graph and see this part here is above the line y equals x. So we can say this is positive. And this part of the graph here is below the line y equals x, so it's negative. So we can say that the critical point square root of 2 is going to be a maximum because the signs change from positive to negative. And this point here, if you look on the graph, at x equals 3, nothing really happens. So this will be neither a max or a min.